Hello everyone, myself Hans. Today we are going to solve the problem of differentiation under the sign of integration problem and based on Leibniz rule of. Here in the question, evaluate 0 to pi by 2 integral log alpha square cos square theta plus beta square sin square theta d theta where alpha is greater than 0 and beta is greater than 0. Let's solve the problem. Given integral is this is equal to I, this is 0 to pi by 2 log alpha square cos square theta plus beta square sin square theta into d theta. Let this equation 1. Here is the parameter alpha, so differentiating equation 1 with respect to parameter alpha, that is di upon d alpha is equal to, here is 0 to pi by 2 limit, integration limit, and we know that the differentiation of log x is 1 upon x, so we have to write that is 1 upon of alpha square cos square theta plus beta square sin square theta, and again we have to differentiate in the bracket present, that is alpha square cos square theta, differentiating with respect to alpha, that is into 2 alpha cos square theta, and this is d theta. Further, we can also write that is 0 to pi by 2, and this is 2 alpha cos square theta upon alpha square cos square theta plus beta square sin square theta, and this is d theta. Dividing cos square theta by numerator and denominator of right hand side, that is di upon d alpha is equal to, here we divide numerator, we get 2 alpha, integral limit is 0 to pi by 2, and cos square theta to cos square theta is removed, so remaining is 2 alpha upon, and here is alpha square plus of beta square tan square theta, and this is d theta. Further we have to let tan theta is equal to t, and from here we get differentiation of tan theta is sec square theta, and d theta is equal to dt, and we have to find the value of here d theta, and d theta is given by d theta is equal to dt upon sec square theta, and sec square theta is written as dt upon 1 plus of tan square theta, and putting the value of tan square theta, that is d theta is equal to dt upon 1 plus of t square, and here we have to change the limit. When we have to put theta barabar 0, we get t barabar 0. When theta barabar 0, we get t barabar 0, and we get theta barabar pi by 2, then t barabar infinity. The value of tan and t is infinity, so we have to put here, that is di upon d alpha is equal to 0 to infinity, and we have to 2 alpha is taken into outside, that is 2 alpha, and the remaining is here 1 upon of alpha square plus of beta square, and we have to let tan theta is equal to t, that is tan square theta is t square, and putting the value of d theta, that is d theta is given by dt upon 1 plus of t square. Further we have to multiplying numerator and denominator of right hand side by beta square minus of alpha square. We have to multiplying, that is di upon d alpha is equal to 2 alpha upon beta square minus of alpha square, and we can also multiply the numerator, that is 0 to infinity, and here is beta square minus of alpha square upon this is alpha square plus of beta square into t square, another bracket, that is 1 plus of t square, and this is dt. Further, in the numerator we have to add and subtract beta square plus of t square. We can also write, that is once again this is given by 2 alpha upon beta square minus of alpha square, and this is integral limit is 0 to infinity, and here we have to add and subtract, that is beta square minus of alpha square is already present. We have to add and subtract, that is plus of beta square t square plus of beta square t square and minus of beta square t square upon, in the denominator this is alpha square plus of beta square into t square, and another bracket is 1 plus of t square, and here is dt. Further we have to solving that is di upon d alpha is equal to, we have to take this is 2 alpha upon beta square minus of alpha square, and integral limit is 0 to infinity, this is infinity, and taking beta square and beta square t square in one bracket, once again beta square, taking beta square and beta square t square in one bracket upon this is alpha square plus of beta square into t square, and another bracket is 1 plus of t square, and this is minus of alpha square and minus of beta square t square, taking one bracket, it is minus of alpha square beta square, this is minus is taking common, that is alpha square plus of beta square into t square upon, here is alpha square plus of beta square into t square, and another bracket is 1 plus of t square. This is given by dt. Further we have to solve, this is given di upon d alpha is equal to 2 alpha upon beta square minus of alpha square, and here is integral limit is 0 to infinity, and from here we can take from beta square is taking common, that is beta square and 1 plus of t square, and upon here is alpha square plus of beta square into t square, and another bracket is 1 plus of t square, and minus of here is alpha square plus of beta square into t square upon here is alpha square plus of beta square into t square, another bracket is 1 plus of t square, this is dt. From here alpha square plus beta square t square to alpha square plus beta square t square is cancelled out, and from here 1 plus of t square to 1 plus of t square is cancelled out, and the remaining is remaining is given by di upon d alpha is equal to 2 alpha upon beta square minus of alpha square, and the integral limit is here. One integral limit is taken to the bracket, that is 0 to infinity, and this is beta square upon alpha square plus of beta square into t square, and this is dt minus of 0 to infinity integral limit here is 1 upon of 1 plus of t square dt, and we know the following identities in the integration, that is dt upon 1 plus of t square is given by tan inverse of t, and we can also know that that is integration of dt upon a square plus of t square is given by 1 by a tan inverse of t by a. We use the following two identities here, that is further di upon d alpha is equal to 2 alpha upon beta square minus of alpha square, and here is integral limit is 0 to pi by 2, sorry 0 to infinity, and the numerator project we have to beta square, and from denominator we have to take common beta square is taking common, that is alpha square upon beta square plus of t square, and this is dt, and beta square to beta square is cancel out, and minus of integral limit is 0 to infinity, and this is 1 upon, we can also integrate these terms, and we can write it as this is tan inverse of t, and here we have to put the limit also, that is 0 to infinity. Further we have to solve. We can also assume here, that is this is given by, once again, this is given by di upon d alpha is equal to 2 alpha upon beta square minus of alpha square, and the bracket is open here. This is integral limit is 0 to infinity, and 1 upon of alpha plus beta का whole square plus of t square dt, and minus of, here we have to put the limit. When we apply the upper limit, tan inverse in place of t we have to put infinity, we get pi by, the value of infinity is 10 pi by 2, so from here we get minus of pi by 2. And further we have to solve this integral. We using the following format, is a square plus t square dt upon square upon t square is given by 1 by a tan inverse of t by a. This is given by di upon d alpha is equal to 2 alpha upon beta square minus of alpha square, and this is given by 1 by a. This is 1 upon alpha upon beta, this is given by beta upon alpha, and tan inverse of x by a. Here is x is t upon a, this is alpha upon beta is a, so we have to put here alpha upon beta, so we can directly write this is beta upon alpha, and applying the limit here, this is 0 to infinity, and here is minus of pi by 2. Further we have to solve. This is di upon d alpha is equal to 2 alpha upon beta square minus alpha square is written as beta plus of alpha and beta minus of alpha. Using the following identity, that is a square minus of b square is written as a plus of b, and another bracket is a minus of b. We can write here, and we have to put the limit here when beta upon alpha, this is beta upon alpha is taking outside and putting here in place of t, that is infinity, and infinity is multiplied with any number, we get infinity, and the value of tan 90 is infinity. So from here we get pi by 2 minus of pi by 2, and from here we get pi by 2 is taking common, that is di upon d alpha, and this is 2 alpha upon beta plus of alpha, and here is beta minus of alpha, and from here we have to get pi by 2 is taking common, and the remaining is here beta upon alpha minus of 1. And further we can also write, we can also cancel the terms, 2 to 2 is cancelled out, and the remaining is pi alpha upon beta plus alpha and beta minus of alpha, and we have to take LCM here in the bracket, we get beta minus of alpha upon alpha, and from here alpha to alpha is cancelled out, and alpha to alpha is cancelled out, and beta minus alpha to beta minus alpha is cancelled out, and the remaining is di upon d alpha is equal to pi upon beta plus of alpha. On integration, that is di is equal to pi, and this is given by pi upon beta plus of alpha into d alpha. On integration, we can integration of di is given by I, and here pi is taking constant, and outside, and d alpha upon b plus alpha, this is given by log b plus alpha, and taking constant here c. Further we have to solve. We have to putting in equation 1, alpha is equal to beta, we get the value of I. Then we have to further solve. Putting in equation 1, this is equation 1, alpha is equal to beta, that is I is equal to, this is 0 to pi by 2 in place of log, and this is given by alpha square cos square theta, and in place of beta we can also put alpha, that is alpha square sin square theta, and this is d theta. And further we have to take common, I is equal to 0 to pi by 2, and this is, we can take a common, that is alpha square is taking common, that is log alpha square, and this is given by cos square theta plus sin square theta. And we know that in the trigonometry this is given by cos square theta plus sin square theta is given by 1. So we have to write here 1. This is given by I is equal to 0 to pi by 2 log alpha square d theta. And we have once again alpha square I is equal to pi by 2 log alpha square d theta, and we can also write this is once again we can also write, that is, with the property of log, that is 0 to pi by 2, and taking log alpha square is parameter, we have to take a constant, we have to outside, it is 2 log of alpha, and the integral limit is 0 to pi by 2, and here is d theta. On integration of d theta is given by, this is I is equal to, once again, I is equal to 2 log alpha, and this is integration of d theta is theta. When putting the value of pi by 2, this is pi by 2, and from here 2 to 2 is cancelled out, this is equal to pi log alpha, and we have to put here the value of I. putting the value of here I we have to find using equation 1, that is pi log alpha is equal to, here is pi log, this is beta plus alpha is plus of c, and further we have to write this is, once again to find the value of here, this is the value of I, and putting here in the equation I is equal to pi log beta plus alpha plus c, and from here we get the value of c, this is pi log alpha minus of pi log beta plus of alpha is equal to c, and using the property of log, we taking first common pi, this is log alpha minus log beta plus of alpha, and this is equal to c, and log m minus n is written as log m upon n, this is pi log alpha upon beta plus alpha is equal to c, and we have to putting the value here, the once again log alpha minus log beta, we get the value of I here, and putting the value of I here, once again we get the value of alpha, this is I, and we have to put here, we have to put in place of I, this is once again I is equal to, this is given by pi log beta plus of alpha, and the value of c is we have to calculate, this is pi log alpha upon beta plus of alpha, and from here we can also take a common, this is pi is taking common, this is log beta plus of alpha and plus of log alpha upon beta plus of alpha, and this is given by log m plus n, this is log mn, and this is the required solution. This is the required solution of the given problem. Once again we check the answer. Once again, when we have to calculate the value of c, we have to put alpha is equal to beta. So we have to put here, that is alpha is equal to beta, this is alpha and this is 2 alpha, we can write this is 2 alpha, and 2 alpha, this is also 2 alpha, and from here using the property of log m minus n, this is alpha upon 2 alpha, that is alpha 2 alpha is cancelled out, and the value of c is, once again the value of c is given by pi log 1 by 2, and we have to put in the here, we have to put in here, that is this is I is equal to pi log beta plus of alpha, and we have to put in the value of c, that is c is given by pi log 1 by 2, and from here I is equal to taking common pi, and this is given by log beta plus of alpha and plus of log 1 by 2, and using the property of log m plus n, this is log mn, we can also write, and this is also stop here to record solution, and we can also write log m minus of n, that is I is equal to pi log, this is beta plus of alpha into 1 by 2, and we can also write that is pi log beta plus alpha upon 2. This is the required solution of the given problem. Thank you class and thank you for watching.